Does it? So if we have 4 terms, are the 2 inner terms both 4, or does it go 4 twos?
You know what it really does? It really does this. For one of the parabolas inside, the coefficients really are 1, 4, 1. But the next one overlaps this one, 1, 4, 1. The next parabola overlaps this one, it shares its endpoint, I should say, 1, 4, 1, et cetera, et cetera, et cetera. That's why going from outside in, your coefficients end up being 1, 4, 2, 4, 2, 4, 2, 4. That's really where it comes from.
So,
and you can see the 1, 4, 1 business when you saw me derive since we were in linear class.
So the number at x n minus 1 is going to be 4?
Yes, the coefficient you mean.
Yeah.
For the f eval at x of n minus 1 is definitely going to be 4.
Okay.
And by the way, something else that's important here is that you can't use this rule unless you have an even number of subintervals. Yeah. So David, can I make that announcement we talked about this weekend?
Do what?
Notes.
Oh, yeah, sure.
Dave's been taking really good notes. So if you guys are interested, I'm just going to create a link on my website, hopefully today, so that you can access the notes if you're interested. He just does really nice notes.
Just print them off.
Something else is that I don't know if you guys remember this, because I didn't bring it up in class on
It's a
Thursday.
huge folder of notes, like
But
everything.
we agreed that voluntarily, Saturdays are now open at 10 o'clock.
Yeah.
So if you're interested, we're all meeting on Saturdays at 10 o'clock. Purely voluntary, you don't have to be there. This last Saturday, how many of us were there?
6.
Just 6 of us, 6 students. Okay.
Where?
The Starbucks on Blue Oaks. Do you know where the Blue Oaks Cinema is? That shopping center has a Starbucks. One.
It's so funny.
And I wouldn't want to be selfish. It's just really close to work.
That's where Deborah and I meet for movies.
Oh, is it really?
Yes.
Gotcha.
How convenient.
Guys, any questions on the homework? Ooh, how nice. Can I mention something about one of the questions in homework? Oh, I can't. I gotta wait this before.
I have a question, sort of, about the homework.
I'm all ears.
Can you maybe give us a rubric or something of all the different terms of proportionality? So jointly proportional,
Yes,
inversely
I can.
proportional, and how they translate
There
mathematically?
are not that many, but
Yeah.
here's what you need to know. So I think in each one of these sentences in English, I'm talking about some kind of proportionality. But for me to say that y is directly proportional to x simply means this, that y is equal to some constant times x. Now I think my choice of words is pretty appropriate, because to say that y directly is directly proportional to x kind of implies that if one gets bigger, the other one does. And in case just constant, particularly positive constant, certainly it is the case that as x increases, so does y, and vice versa. Now to say that y is indirectly, or sometimes I'll say inversely proportional to x, simply means that y is still equal to a constant times something. It's just as when an indirect or inverse proportionality is going to be 1 over x. Kind of makes sense, doesn't it? Now as x increases, y is going to decrease if k is a positive constant. Now to say that y is jointly proportional to x and z simply means y is equal to some constant times something again. It's just that with that adverb jointly, it means I'm proportional to 2 things. And maybe there's a variation on the English in that I could say y and x are directly proportional to each other. Down here I might say there is a joint proportionality from y to x and z. You know, I could change the words a little bit, but those are the three types of proportionality you might have. And I can make x and z more sophisticated. I could have said y is jointly proportional to the square of x and the square root of z, which means they look a little different over here. But as far as the choice of words for joint proportionality, that's
Okay.
roughly the same. I think that's all you have to worry about.
Okay.
I'll try to, I want to do it this week, and I'll try to create some more examples.
Okay.
Is there, this might sound ridiculous, is there inversely jointly proportional?
It's right there.
No. If I wanted to finagle that,
Oh,
I can force it to exist, but I'd rephrase it this way. Y is jointly proportional to the tangent of x and the reciprocal of z. So I think it'd be a little more clear if I said things that way. And now y is therefore is going to be equal to k times, I don't know, you guys finish this up.
Tangent x.
1 over z.
Yeah, something like that. Do you guys agree? Does that help you?
Yeah.
Can I mention something about the homework?
Is it about number 2?
I think so, to be honest, I have to look. I don't really remember. David brought something up to me this morning. You guys, I don't do things like I'm doing this summer session typically. Summer sessions, I teach my 31 students how to solve DEs with separation variables technique. And there's another technique called technique for solving first order linear differential equations. And the author text actually mentions it, but he mentions a very special sub-case scenario of it that wasn't generalized at all. And I teach a much more generalized version. So let me tell you what happened when I wrote this. I had that number in there. Which means the amount of water coming in is less than the amount of water going out. So when you read my final question, it made sense, which is how much pollutant is in water, collection system, when it's half full? Just skip that question. Because I changed it, and therefore it doesn't make any sense. Just solve the DE. I apologize for my sloppiness. I just changed things halfway through. I typed that up first time around, and then backed up off plan. So now,
should we know how to solve it if it was changed? Because I don't.
if I had a 1.5 in here, you would not be able to solve this DE. It would not be a separable DE.
Okay.
So would you treat it as a, because when I was looking at it originally, I was, the one thing that kept popping up in my head is related rates. So, because you have something that's decreasing at a constant rate, and I was trying to figure out how to approach it that way. Is that, when you say the first order derivative, or the first order whatever, would that be how you would approach it as?
I think this question has nothing to do with related rates. Let me show you why. Because I think the rate at which the amount of pollutant is changing over time is equal to the rate coming in. Can I just call it constant? Whatever it is. Minus the rate going out, which might be 1.5 gallons per minute. I just have to multiply it by the concentration of pollutant in this tank, or whatever this thing is, as time goes by. But I think the concentration is the ratio of the amount of pollutants in there. Measured in, well, whatever my units are in this example, is it grams? To the amount of fluid in the tank at time t is just the amount of fluid in the tank at time t is not a constant anymore. It ends up increasing, isn't it? I've got a total of 1 gallon per minute coming in, but 1.5 going out. And so I think the volume is however much it was initially. 100 gallons. Minus a half a gallon per minute. And now let me suppress my units. That is not a separable DE. I will not be able to rewrite this DE in such a way that dPdt is equal to, I don't know, some function in t times, some other function p? Is it not a
Do
separate?
you mean 3/2?
Oh, do I mean 3/2?
Because 1.5 now.
I don't think so, because the amount of fluid coming in, if you add those three
Oh, I
rates,
see,
you have
I
this
see,
is
I see,
positive
I
one,
see, I see.
but there's a 0.5 going out.
So what are you saying on this, that we should change it to 1.5?
No, I'm saying, let me show you the mistake I truly did make. When I typed this up, I thought I was gonna get to solving a different type of DE, and there's what I had typed in there. With that question, everything makes sense. But then when I actually put this online and posted everything, I realized I'm not gonna go that far. I changed a 1.5 to a 1, but didn't read the rest of my question. Now this question has no meaningful interpretation of what's in the scenario.
Okay.
So cross that question out, just solve the DE.
Okay.
That's all I want you to do. But again, I'm being honest, I usually go a little bit further. Anything else? Awesome.
Could you maybe do the fourth one real fast?
I'll do whatever you like.
Okay.
Set it second one. Well, for the second one, let's just talk about, let me be careful with my language, it's a water collection system. Okay, so it's not a tank. But it does have 3 supplies coming in. The first at this rate. The second one at this rate. The third one at this rate. You guys might have to jump around a little bit. But the amount of water flowing out of this particular water collection system is 1/10 or 1, excuse me, it's 1 gallon per minute. Now let's just stop for a minute. I know I'm missing a lot. I need to put more in my picture to be able to write a differential equation. But in terms of fluid flow, you have to confess, the amount of fluid coming in, bless you, is a full 1 gallon per minute. The amount going out is the same darn quantity. And so I think over time, the amount of water in the tank's really not changing, is it? All right, I got to go back and give some more details. The first flow of water coming in has a concentration of a pollutant algebranium at 5 gallons, or 5 grams, excuse me, per gallon. The second has a concentration of 2 grams per gallon. And the third one is clean. It is a case the tank is initially full and has a capacity of 100 gallons of fluid and contains 310 gallons of this pollutant. Can I underline that? Because I'm going to forget that. Let's see if you and I can't write a differential equation, mathematically modeling the amount of pollutants in this tank at the time t, and solve that differential equation. And I think the rate at which the amount of pollutants coming in is changing over time is nothing more than the rate at which the amount of pollutants coming in minus the rate at which it's going out. You guys, can I rephrase this? Let's just for a brief moment not concentrate on pollutants. Let's talk about fluid flow. I think my 3 fluid flows coming in are 1/10, 3/10, and 6/10. But when it comes to the first fluid flow, there's a concentration of 5 grams per gallon, and so I think what's above this brace right here is really the rate at which the pollutants are coming into the tank from the very first water flow. I'll add to that the rate at which pollutants come into the tank from the second water flow, but that's not it. That's not the rate at which a pollutant is coming in. That's just the rate at which water is flowing into the tank from the second stream coming in. I think I need to multiply that by the concentration of pollutant to get the rate of flow of the pollutants coming into the tank from the second water stream. As far as the third one's concerned, if you want to put it in, go for it. I don't. But you're going to have to multiply it by its concentration of pollutant, which is just 0, it drops out.
So on the test, Do you want us to carry through the units of measurement, or do you
No,
mind
as a
if
matter of
we
fact, in
don't?
class, when I first gave an example of this, I put the units in there only so that you could believe me that I was not making a mistake.
Okay.
And I wanted you to understand that my units were consistent for all those terms, which meant it was legal for me to add and subtract those terms.
Okay.
I think that as far as the rate at which the amount of pollutants leave in the tank, I better subtract it off. Rate of flow of fluid is this, 1 gallon per minute. But the concentration of pollutants in the tank at time t, not only was it not given, I don't think it's constant. But I can interpret it as a ratio of the amount of pollutants in my tank at time t measured in grams to the amount of fluid in the tank at time t, which actually is just a constant of 100 gallons. And I think this will give me the rate at which the amount of pollutant in my tank is changing over time. And so I think my final DE looks like this. dAdt equals, I don't know, is that 11 tenths?
Where does the initial 310 grams? It's a 0.3 gallons.
Oh, you mean what's underlined in red? The
Yeah.
310 grams? Good question, I'll get to it. That's why I underlined it, because I had a feeling I'd forget about it. Notice it's nowhere near though, yet. And am I subtracting off? Over 100. Well, you know what, you guys? That DE is separable. I can solve that differential equation. It's just that when I solve it, yes or no answer, you guys, watch. Am I not going to come up with a function for A in terms of t equals some chunk, maybe plus some constant along the way, or maybe times the constant? And I'll be able to find the constant by using my initial value condition. That the amount of pollutants in the tank at time t is going to be my 310 grams. That's where it comes into play, so I can solve for that constant at the end. Is that okay, Deborah? Did I go through it too fast?
Almost what I have is, I couldn't handle the constants, is what it was.
Gotcha.
I didn't know what to do with it.
Gotcha. And Brad, you said number 4.
Yeah, if you could.
It's such a small class, I heard almost a 2-ring session. Now that looks nice. So the rate at which a population of Archimedeum subcutaneous bacteria is growing is jointly proportional to the square of the population and the difference between the population and its carrying capacity. Oh, look at that. I gave the DE. Solve this differential equation if the carrying capacity is 5 grams and given these two boundary value conditions. Well, to solve this differential equation, let me first rewrite it. I said dPdt is equal to p squared. Oh, sorry, I misspoke. I meant to say k times p squared times 5 minus p. Now, I do think this DE is separable. Keep in mind that when it comes to k, it's just a constant. So when I separate variables, I don't care where you place the k. Keep it on the right-hand side, or maybe divide both sides by k to bring it to the left-hand side. In the end, it makes no difference whatsoever. And in separating variables, I think I'm left with this. Now, clearly, my technique for solving or for evaluating the integral on the left-hand side is going to be partial fraction decomposition. I agree. So pulling out a piece of scratch paper. Let's take this fraction. Decompose it into some of these 3 fractions. Namely, something over p plus something over p twice plus something over 5 minus p. Now, it's my mathematical responsibility to dive in here and solve for A, B, and C, find out what those constants are. And you guys got to confess, if I can accomplish this task, it's going to make my life a lot easier. It's going to make my life a lot easier because, in the end, what it means on the left-hand side is I'm integrating something over p plus something over p squared plus something over 5 minus p. And that would be an absolute piece of cake to value as an integral. That's the whole point behind partial fraction decomposition. So let's find those constants. Let me clear fractions. 1's equal to this plus this. Well, actually, I misspoke, didn't I? I missed it back. Plus b times that binomial plus c times p to the 2nd power. You get tired. You want to beat the clock, so if you guys don't mind, I'm not going to equate all the coefficients, build 3 equations with 3 unknowns. I'm going to cheat a little bit. I'm going to allow p to be the zero of one of those linear factors, namely 0 itself. I think the first and third groupings on the right-hand side, completely gone. And I think what it basically tells me in the end is that b is equal to 1. Continuing in my lazy fashion, I will now allow p to be the zero of the other linear factor, namely positive 5. But jeepers, this time on the right-hand side of the equal sign of this equation, the first and second groupings drop out, and I'm merely left with a b, or excuse me, c being equal to 1/25. And lastly, I'm running out of quick shortcuts, you guys, darn it. I guess at this stage of the game, I will have to equate coefficients. How about coefficients of p squared? And equating coefficients of p squared, on the left-hand side I get a 0. But on the right-hand side, I get a negative a plus c. I said negative a plus c. So I guess that tends to tell me that a itself is positive 1/25. Having said that, I'll slap these values in. So my constants are 1/25, 1/5, and 1/25. Oh shoot, I forgot my right-hand side. I'll put it in real quick. Now, on the left-hand side of the equal sign, anti-differentiating term by term, let's see what that gives me. Does that give me a 1/25 natural log of the absolute value p? Is that a minus 1/5p? And lastly, is that a minus 1/25 of the natural log of the absolute value of 5 minus p? Being equal to my kt plus c. Guys, I'm just slightly disturbed with what I'm writing on the board. I think I've got quite a bit of ambiguity in here. Notice how with partial fraction decomposition I had a c, but now I'm calling my constant integration c. Just to be clear to you, the reader, do you mind if I just slip in a subscript so that you understand they're not the same c's? And next, if at all possible, I want to solve for p. Heck with it. Way too complex. I wouldn't bother solving for p because embedded in both a transcendental function and an algebraic one, there's no way in heck I'll be able to solve for p in terms of t. I do think maybe I can clean it up a little bit. Does this give me 1/25 times the natural log of, I don't know, how can I write this?
C over 5 times p.
Yeah, I guess I can't see anything else fancier than that. I mean, I suppose maybe I could multiply both sides by 25, maybe even 25 times p. Probably wouldn't bother. Oh, something else. Look at the solution I have. It's an implicit solution, not an explicit one, because p is not isolated. But it still relates to population, to time t, with 2 unfortunate circumstances, those constants. So how do I find the value of these constants? I'll plug things in. And when I plug 1 in for t here, 2 in for p, do you guys want to see me do it? Do you want to see me do it?
Sure.
Yes.
No, you don't, because it's too
Right.
hard. It might be easier to use this condition first. After all, if I now use this condition that p is 0 is, I don't remember, positive 1.
It's legal just to plug in those values?
Absolutely,
Okay.
think about it. It's already the case that I know my function actually passed through the point 0, 1 graphically speaking. So I
Okay.
know when t is 0, p is going to be positive 1. It's just that when I plug 0 for t, notice how this first term on the right-hand side drops out. I'm only left with an equation of only one unknown. That's why I'm being a little goofy. I don't want to start here. I want to start there. Make my life easy.
Okay.
And in doing such, I think it tells me that 1/25 times the natural log of 1/4 is minus 1/5, excuse me, is equal to C1. Oh, check that out. That's my constant C1. Let's see when I rewrite. So I guess I'm left with 1/25. Natural log of the absolute value of this ratio. Minus a 1/5p. being equal to a k times c plus my c1, where here's my c1. Now, I think I can find the value for k by now using the other condition, namely the p of 1 was, I don't remember, is it positive 2?
Mhm.
And in using that, I guess what I have now is a 1/25th. Natural log of 2 over 3, if my arithmetic's okay, minus a 1/10. You guys, can you read that? That's a p. Is equal to k times t, where t at this particular point in time is positive 1. Oh, plus some more nasty constants. Now you guys just allow me to solve for k. Subtracting 1/25th natural log of 1/4, holy cow, minus? Is that a 1/25th natural log of 8/3? I can tell you guys are going to make me do all the work again. Yeah, looks good. Is that a plus 1/10? Oh no, I'm running out of board space. Yikes. I guess that tells me then if I can sneak, can I just sneak down in the middle of this board if I'm not being too sloppy and disorganized? I think picking up that k value right here, I'll put in forward, slapping it in, watch this. Right there. Big as it follow. 1/25th. Natural log of the absolute value of this ratio. Minus 1 over the product of 5 and p is equal to my k value. Times 2. Plus my c sub 1 value. Is that my, right here, 1/25th? I don't know, you guys, is there anything else I can do?
You can multiply everything by 25.
You know, at this stage of the game, I think that would look nice.
You can add a 1/25th 5 ln of 1/4 to the other side and combine like terms if you really wanted to.
Yeah, I could. Or at minimum, maybe after distributing this multiplication of the addition, combine these two at minimum.
Okay.
No, I agree. At this stage of the game, I really would have gotten rid of fractions. Are you guys happy?
Yeah, it just looked really scary when I did it, so I just needed to.
Yeah.
So what language are we looking for to know if we have to isolate P and just if it looks really complex enough to do it?
Yeah, how about this? No language. If it's convenient and it looks nice to solve for P, do it. And a lot of times, like in this example, I just can't solve for P algebraically. I have no techniques to do it because P was embedded in both a transcendental and an algebraic function on the left-hand side. Yes, Cal?
So, I was under the impression that we should always try to solve for P when we can.
Yes,
Obviously,
you should
we
always
can.
try to solve for P if it's feasible.
Okay.
In this example, by far, it's not feasible whatsoever.
And then, so how would we, if we ran into this problem, in an example like number 2 where we were supposed to solve for something, or where we're supposed to see where, I don't know, volume of water is at a certain time, would we just,
I was just hoping through those first few examples you would have been proficient enough at that point to be able to tell.
okay, so we would just plug in the time for T, because I know we talked about this on Saturday, P is equal to, or P
And
means.
P of T.
Yeah, P of T, so, at this point I would be lost.
Really? Shoot. That makes me nervous because I'm not going to be here when you take your exam. Just try to get more practice.
Okay.
Try to get more practice. How many of you in this room, because I really have lost track, I didn't write units down the first day of class. How many of you are in the middle of this calc sequence by taking it somewhere else? Taking calc points somewhere else? And so for those of you using different books, you know, you can always just type in there and get more examples if you want. Get more practice. So guys, is there anything else you want to look at before I get started today? Yes?
Where do you get the element of 8/3? You just did common denominators on both sides and then did a common denominator again.
Oh, quite the contrary. There's a lot of steps in there. I'll show you. First things first. I brought these two terms to the left-hand side, and I did it in this order in my head. Here's the first term on the left-hand side, minus the second term on the right-hand side. Here's the second term on the left-hand side, minus the third term on the right-hand side, is equal to my k. Then I pulled out a 1/25th from these two terms involved in my natural log. I combined these two fractions. But then I realized I had the difference of two logs inside that set of parentheses, and I rewrote them as a log of a ratio. Then I inverted and multiplied and came up with my 1/25th. Natural log of 8/3 plus 1/10 equals k, but I did it in my head, and hopefully I didn't make a mistake, did I? Oh, thank goodness. That's what I had before. I was,
Is that what we were supposed to do in our heads?
I was kind of hoping so, yeah. It's just math D, isn't it? Really, that really is math D.
It's true.
No exaggeration.
Real quick, can
Yes.
you just, I guess, box the answer, or what you would be looking for as an answer to this question?
Well, now that when I use those boundary value conditions, I have so many fractions created in there. Can I just clean up just a little bit before I answer your question? You guys help me. Can I get rid of this?
Sure.
Now that I use those boundary value conditions, multiplying both sides by 25, I think would help. And I think that gives me natural log of the absolute value of this ratio minus 1 over p being equal to natural log of 8/3 times t plus t times 1/10 plus, hold it. I said I multiplied both sides by 25. Got rid of that one, but when I multiply this by 25, doesn't that give me a 5/2?
It gives you 5 on the other side as well.
And then my plus natural log of 1/4 minus 5. And David said, check this term out right here. When I multiply that by 25, 5's canceled, but I am still left with one upstairs on time. Anything else I can do? I'll actually hold it, you guys. This looks too sloppy. Sorry. No, I'm not going to change it, but that was a plus, I think. Natural log of 1/4? It was a minus 5? Now, at minimum, I think I combine these two logs. Or can I conveniently?
Yeah.
Yeah, I suppose I could if I brought this t up in the exponential position. I don't know if that looks very clean at all. Actually, to be honest with you, I probably would have stopped. I don't see anything else I could do. So
You
Tyler,
could,
I don't know.
Okay, so
This would work.
You could subtract a natural log of 1/4 from the other side and combine it with the natural log of p over 5 minus p.
Yeah, I could. Got to throw 4 upstairs. I mean, that might be something nice to do. How much else I can do? And maybe to not multiply both sides by 25, you got that instead. I mean, I can live. I think earlier, Tyler, I was suggesting you can combine these two. It just doesn't look very nice if I do it, so I probably would.
okay.
You guys, anything else before I change the name of the game today, dramatically?